Hey everyone, today we are going to solve the Daily LeetCode challenge of 4th January 2024, and the problem statement is minimum number of operations to make array empty. Let's first understand the problem statement. So according to the problem statement, we have been given an integer array nums, and we have to find out that what is the minimum number of steps to make this array empty. So we have to find min number of steps to make this array empty, to make nums empty. Now, how can we make this array empty? We can make this array empty by deleting these elements. Now, for deleting these elements, we have two conditions. Now, what are those conditions? The first condition is we can delete two equal values. Delete two equal values in one go. And the second condition is that we can delete three equal values in one go. Okay, so let's understand this with the example of this test case. So we'll start by deleting this 2. So we can delete this 2 and this 2, like by following the first condition, that delete two equal values. Now you might ask that why are you deleting this 2 and this 2 only? You can also delete this 2 because we can follow the second condition in that case, that is delete three equal values. Now you might see that if I'll delete this 2, and this 2, then I'll be left only with this 2 in my array. And will I be able to delete this 2 in the future? The answer is no. Why? Because the condition is that delete two equal values or three equal values, and this 2 is alone. So we can't delete this 2. And eventually we won't be able to make this array empty. That's the reason why at the initial stage, we will delete only these two. That is, we'll delete this 2 and we'll delete this 2. So for deleting these two 2's, we are taking a step of 1. Now, we'll see that we have a 3, we have another 3, and we have this 3. So the count of 3 is 3. So we can delete these 3 in one go by satisfying the second condition, which is delete 3 equal values. So we have taken 1 steps to delete 3 3's. Now I'll come here. We can see that we have two 2's. So we can delete this 2 and this 2 by following the first condition, which is delete two equal values. So we have now again taken a step of 1. Now we are left only with two 4's. So we'll delete this 4 and we'll delete this 4, and it will take a step of 1. So we are taking total a 4 step to make this nums array empty. Now let's see how we can approach this problem. First of all, let's say these are the counts. So we know that if a count of a number is 1, then what will be the answer? The answer will be -1. Why? Because we can delete two elements, two equal values or three equal values in one go. If we have an array in which there is only 1, 2, so will we be able to empty this array? The answer is no. Why? Because we don't have any other 2 to pair this 2 with, right? So we can't make this array empty. So in that case, we have to return -1. Now, if we have the count of an element as 2, then what will be the result? The result will be 1. Say for example, in an array, I have a 4 and I have another 4. So in one step, what we can do? We can remove both these 4s, right? Now, if a count of a number is 3, how many steps will we take to empty that array? The answer is 1. So say for example, in an array, I have 5, 5, 5. So I can follow this second condition, which is delete three equal values. So in one step, I'll be able to delete all these three equal values, right? So the answer would be 1. Okay. Now let's say the count of a number is 9. Then what will be the answer? So the answer would be, how we can solve it? We can say, okay, it's 9. So I'll remove 3. Then I'll remove again 3. Then I'll remove again 3, which will be 0, right? First, we can remove 3 values from this 9. So we'll have, first we'll remove 3, we'll have 6. Again, we'll remove 3, we'll have 3. Again, we'll remove 3, we'll have 0. So how many steps we are taking? We are taking 3 steps. How many steps we are taking? We are taking 3 steps. Okay. So if we have a number like 12, what we can do? We can say, okay, 12 minus 3, minus 3, minus 3, minus 3. which would be 0. So from 12, we are first deduct 3. So we'll be left with 9. Then again, we'll deduct 3. We'll have 6. Again, we'll deduct 3. We'll have 3. Again, we'll deduct 3. We'll have 0. So how many steps we are taking? It's 1, 2, 3, 4. Now, if we have numbers like, if we have count as 4, 7, 10. So first what we'll do, if we have 4, we'll remove 2, and we'll get a 0. So how many steps we are taking? We are taking 2 steps. If we'll have 7, what we'll do? We'll remove a 2 and we'll remove another 2. So what we'll have? We'll be left with 3. So 7 minus 2 is 5. 5 minus 2 is 4. And we'll be left with 3. So we can remove this 3. We'll get a 0. So how many steps we are taking? First, we are removing 2 2's and then we are removing a 3. So we are taking a total of 3 steps, right? Now, in this case, when we have a 10, so how can we solve this? We have a 10, so we'll remove a 2. We'll be left with 8. After removing 2, we'll be left with 8. We'll remove another 2. We'll be left with 6. We'll remove now what we'll do? We are left with 6, right? Now what we can do from this 6, we can remove a 3 and we can remove another 3. So we'll have 0, right? So how many steps we are taking? 1, 2, 3, 4. We are taking 4 steps, right? Now coming to when we'll have something like 5, 8, and 11. 5, what we can do is we can say 5 minus 2 will be left with 3. Then we can say 3 minus 3 will get a 0. So how many steps we are taking? We are removing first a 2 and then we are removing a 3, which is 2 steps. Then for 8, what we can do? We can remove a 2, we'll be left with 6. What we can do? 6 minus 3 minus 3. Get a 0. So how many steps we are taking? 1, 2, 3 steps. Now coming to 11. How we can reduce this? We can remove a 2, we'll get 9. Then we can say that, okay, 9 minus 3 minus 3 minus 3 will get a 0. So how many steps we are taking? First, we are removing a pair and then we are removing a triplet, again a triplet and again a triplet. We are taking total of 4 steps. Okay, here you can notice that what are these 9 and 12? These 9 and 12 are a perfect multiple of 3. Means if I have something like 3 into x, I'll get these two. Like we can say that 3 3s are 9 and then 3 4s are 12, right? And what are these 4, 7 and 10? They are nothing but 3 into x plus 1. So we can find it out. Like 3 1s are 3 plus 1, 4. Then we have 3 2s are 6 plus 1, 7. Then we have 3 3s are 9 plus 1, 10. And coming to here, what are these? These are nothing but 3 into x plus 2. So if we have 1, 3 1s are 3, 4, 5. This is 5. If we have 2, 3 2s are 6, 7, 8. This is 8. We have 3, 3 3s are 9, 10, 11, 11. Now what I am trying to say is that we can figure out one thing from here. That whenever we are having something like 3 cross x plus 1, what we are doing? We are removing certain pairs. And what is the count of pairs? From every elements, we are removing 2 pairs to make it a multiple of 3. So after removing 2 pairs from 4, we have a 0, which is a multiple of 3. After removing 2 pairs from 7, we are getting 3, which is a multiple of 3. After removing 2 pairs from 10, we are getting 6, which is a multiple of 3. And coming to here, when we have something like 3 cross x plus 2, what we are doing is we are removing one pair. So we are removing a pair from 5 to get a 3, which is a multiple of 3. We are removing a pair from 8 to get a 6, which is a multiple of 3. We are removing a pair from 11 to get 9, which is again a multiple of 3. So what I am trying to say is, what our approach will be is, first of all, we'll take a hash map. Why are we going to take a hash map? Because it's clear that we have to deal with the counts. We have to deal with the counts of the numbers, right? Of each of these numbers present in the nums array. So to keep track of their count, we are going to take a hash map in which our key will be the elements of the nums array and our value will be their frequency. Now, once we have stored the elements and their frequency, what we are going to do is we are going to iterate over this hash map. and we will check their frequency. We'll first check if the frequency of any element is 1 or not. If the frequency of any element is 1, then in no way we are going to make that array empty, because we can't pair that single element with any of the elements, right? Because we won't be able to like satisfy any of these two conditions. So if the frequency of any of the element is -1, sorry, if it is 1, then in that case we'll simply return -1. Okay, otherwise what we'll do, we will say if this is our answer, then we are going to add frequency of that element divided by 3. See, so what we are going to do is we are going to take the frequency, we are going to divide it by 3, and we are going to find out the seal value. Now you might ask me that why am I going to divide it by 3? Why am I not doing frequency by 2 and its seal? Now you can find out that what our question had asked from us. It has asked us to find the minimum value, right? So say for example, if I have a number 12, if I'm going to divide it by 2, then what is the value which I'm getting? It's nothing but 6. And if I'm going to divide the same value by 3, what is the value which I'm getting? 4. So with which number am I getting the minimum value? With 3, right? This is minimum. Out of 6 and 4, 4 is the minimum. So if we are going to divide a number, irrespective of whatever this is, let's take this is n, let's take this is also n. So if I'll divide n by 2 and if I'll divide n by 3, which one will be minimum? Obviously the one which I'm going to divide by 3, because the denominator is greater, right? 3 is greater than 2. That's the reason why we are going to divide it with 3. Now, why are we finding out the seal? First of all, let's understand what seal is. So if we get any decimal number as 2.5, okay. So if we have a number line, and in number line, if we represent this 2.5, so where it will lie? It will lie in between 2 and in between 3. So what will be the seal of 2.5? The seal of 2.5 will be the integer which is just next to it, which is 3. Okay. Similarly, if we have some other number, like say I have 3.2, and this 3.2 will lie in between 3 and 4. So what would be the seal of 3.2? Its seal would be the integer which is just next to it, which will be 4, right? Which is just greater than it. Similarly, like similar to seal, we have another operator which is floor. So if I'll say that what is the floor of 2.5, then the floor of 2.5 would be 2. And if I'll say that what is the floor of 3.2, so the floor of 3.2 would be 3. So in case of floor, what we do, we find the like the previous smallest element. And in case of seal, what we do? In case of seal, we find the just next greater integer to it. Okay. So coming back to the problem. So now we have got the approach that what we are going to do. So now just let's do a quick dry run on this given example. Okay, so here is the nums array. Let's first create a hash map. What we'll have in the hash map, it would be the element and their corresponding frequencies, right? So for 2, we'll first store a 2 and its frequency would be 1. Now we'll come to this 3, we'll have this 3 and its frequency would be 1. Now we'll come to this 3, we already have a 3, so we'll update its frequency to 2. Now we'll come to this 2, we already have a 2, we'll update its frequency to 2. We'll come to this 2, we'll update the frequency to 3. We'll come to this 4, we'll store this 4 and its corresponding frequency as 1. We'll come to this 2, we'll increment its frequency to 4. We'll come to this 3, we'll increment its frequency to 3. We'll come to this 4, we'll increment its frequency to 4. Okay, fine. Now once we have populated the hash map, what we are going to do? Okay, let me write down the steps here. So the first step is what? First is populate the hash map. Okay, now once we have populated the hash map, what we are going to do? We are going to iterate over the hash map. Iterate over the hash map. And what we are going to do? First, like while iterating over the hash map, first we are going to check. First, what we are going to do? Check if frequency equals to 1. So in case when we have a frequency at 1 as 1, then are we will we be able to make that array empty? No. In that case, we won't be able to make that array empty in any way. Say for example, we have a single 2 in an array. Will we be able to delete this 2 ever? The answer is no. Why? Because we can delete two equal values or 3 equal values at a time. Now, I don't have any 2 or 3 equal values in this case. So this array, we can't make this array empty ever. So if we'll check if the frequency is 1, in that case, what we'll do, we'll simply return a -1. Otherwise, like if the frequency is not 1, what we'll do, we'll say that answer plus equal to what? It will be plus equal to ceil of the frequency divided by 3. Okay, so let's come back. So if while iterating over the hash map, the first value which we'll get is 2, 4. So we'll check, is the frequency equal to 1? So no, the frequency is not 1, it's 4. So what will be the ceil of 4 by 3? Now after divide, it would be 1 point something. So what would be the ceil value? The ceil value will be 2. So we'll say that answer, initially our answer was 0. So we'll add this 2 to our answer. Now we'll move to the another element. So the another element is this 3, 3. So we'll again check, is the frequency equal to 1? So no, the frequency is not 1. So what we'll do, we'll find 3 by 3, its ceil value. So it would be nothing but 1. So we are going to add this one to our answer. Now we'll move to another element of the hash map. Now this is the next element. So we'll check, is the frequency equal to 1? So no, the frequency is not 1. So what we'll do, we'll find the ceil value of 2 by 3. So it would be 0 point something. So the ceil value would be 1. Okay. So what is the answer? The answer is, now we'll again move to the next element. So we'll see that we have completely exhausted the hash map. So it means that we have got our answer. So what's the answer? It's nothing but 2 plus 1 plus 1, which is 4 is the answer. So this is how we are going to solve this problem. Now let's quickly write down the code. Okay, so we'll start on by defining a hash map. Let's say this is our map. What this will show? This will show the elements and its corresponding frequencies. Okay. And after that, let's say this is our answer variable, which will store our answer. Now, first of all, what we have to do, we have to iterate over this nums array to populate our hash map, right? Like we have written, what's our first step? Our first step is to populate the hash map. So we'll iterate over nums and we'll say that memo of current plus plus. Now, once we have populated our hash map, what we are going to do, we are going to iterate over this hash map and we are going to check if the frequency is 1 or not, right? So what we'll do for auto current is to nums, sorry, current is to memo. And what we are going to do, we'll say that, okay, our frequency is what? Frequency is nothing but its current dot second. So we'll first check if frequency, let me write it as, okay, I'll check if my frequency is 1. So if frequency is 1, there is no way we are going to make that array empty. So we'll simply return -1. Otherwise, if the frequency is not 1, what we are going to do? We are going to add the ceil of, frequency divided by 3 to our answer. And finally, we are going to return our answer. Now, you will notice that we have done a mistake over here. What is the mistake? If we'll do frequency by 3, we'll always get an integer value. And the reason being that this is the integer division, right? So we can either do 3.0 over here. So this will result in giving us a decimal value, and then we can find its ceil of it. Or another thing which you can do is you can write a double over here. So this will result in giving us a double value, which means it would be present in a decimal format. So we will be able to get its ceil, and then we can simply, after finding its ceil value, we can add it to the answer, and then our result would be correct. So let's run this on our given test cases. So it's giving the correct answer. Let's submit it. So it got accepted. Now, talking about the time complexity and the space complexity. So the time complexity will be order of n. Say for example, if the size of our array is n, then the time complexity would be order of n. Why? Because let's see here. What we are doing here, we are iterating over the complete nums array, right? We are completely iterating over this given array to find the frequency of each of the element. So what we are doing here, it's taking a total of order of n time complexity, right? Now here again we are iterating over the hash map. Now, there can be a case when each of the element of my nums array are unique. In that case, we'll have an entry for each of those elements in my hash map, right? So what does it mean? It means that we are going to have a total of n entries. So if we'll have a total of n entries in my hash map, then it will again cost me order of n time complexity to iterate over them. So it would be total of order of n plus order of n, which will be nothing but order of 2n, which will eventually give us order of n. Okay. And what is the space complexity? The space complexity will be order of n. Why? Because we are storing the elements of the nums in my hash map, and in the worst case, we can have each of the element each of the element of the nums as a unique element. So they'll take total of n entries in them. So the space complexity would be order of n. So that's all for today's daily LeetCode challenge. Thank you.